Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about the P-channel type of field effect transistor. Before we start the construction of P-channel field effect transistor, we know that a field effect transistor is such a semiconductor device in which conduction of current, that is through the channel, and that is because of majority charge carriers. FET is a unipolar type of semiconductor device in which the control of conduction of current is done by electric field, which is generated by reverse biasing the gate. Now let us see the construction of the P-channel type of field effect transistor. We have P-type of semiconductor device which is lightly doped, and from the P-type semiconductor device we have taken two terminals, and that is known as a source as well as drain. So P-type of semiconductor material is act as a channel and majority charge carrier. In case of P-type of field effect transistor, holes are the majority charge carriers. On both the side of the P-type of semiconductor material, we have heavily doped N-type of semiconductor material, which is making a gate. From both the side, it is connected together and it is known as the gate. So this is very basic structure of the P-channel field effect transistor. Now let us see the biasing of the P-channel field effect transistor. We apply voltage across drain and source, and that is known as a drain supply voltage. That is a VDS, and we apply negative voltage to the drain. Same way, we apply voltage VGS across gate and source. We have to reverse bias the gate, and gate is N type of semiconductor material, so we apply positive polarity voltage to the gate for reverse biasing. Let us see the physical construction of a P-channel field effect transistor. We have P-type of semiconductor material as we have discussed, and on both the side of P-type of semiconductor material we have N-type of semiconductor material is deposited. P-type semiconductor material is lightly doped and N-type of semiconductor material is heavily doped. A layer of silicon dioxide is deposited and terminals are taken from the N-type as well as from the P-type of semiconductor material. We have gate that is taken from the heavily doped N-type of semiconductor material, and from the P-type of semiconductor material we have taken two terminals, that is source S as well as drain D, and silicon dioxide, a layer of silicon dioxide. So this is physical construction of P-channel field effect transistor. And let us see the symbol. We have three terminals in case of field effect transistor, that is drain, source and gate, that is equivalent to collector, emitter and base of the bipolar junction transistor. Here we can see the arrow sign on the gate, that is towards outside, meaning is it is a P-channel field effect transistor. And same way we have another symbol also. Any symbol can be used. Now let us see the working of a P-channel field effect transistor. We have P-type of lightly doped semiconductor material which is known as a channel. On both the side of P-type semiconductor material, we have heavily doped N-type of semiconductor material. We have taken three terminals, two terminals from the P-type of substance that is known as drain and source, and one terminal that is taken from the N-type of semiconductor material, and that is gate. Now we have to apply the voltage for the biasing. We apply negative voltage to the drain. When we apply voltage, in case of P-channel type of field effect transistor, the majority charge carrier, that is the holes start passing through the drain and source, and it starts the flow of conventional current through drain to source. The voltage applied across drain to source, that is a VDD, it is known as a VDD, and current start passing through the drain to source. In case of absence of gate voltage, the channel is open, and because it is lightly doped, after application of drain supply voltage, the flow of conventional current is already passes through the channel. But when we apply voltage across the gate and source, and that is a supply voltage VGG, gate is N type of semiconductor material, and to reverse bias the gate, we apply positive voltage to the gate. So once we apply positive voltage to the gate, and based on the level of voltage, a depletion layer is formed in the channel. So based on the voltage, as voltage goes on increasing, the depth of depletion layer also increase. Because P-type of channel is lightly doped, the depth of depletion region is more in channel and it is less in the N-type of heavily doped semiconductor material. There is no charge carriers in the depletion region, and that is why it acts as an insulation and it does not allow the pass of conventional current through it. So based on the application of gate voltage, the depth of depletion region is formed and it will block the drain current. As we go on increasing the gate voltage, the depth of depletion region also increase, and at certain moment it totally blocks the drain to source conventional current, and ID, that is drain current, becomes zero. So current through the channel is controlled by the application of voltage across the gate and source and by reverse biasing the gate voltage. So this is all about the construction and working of a P-channel field effect transistor. Now let us see the comparison between field effect transistor and bipolar junction transistor. We have certain advantage in field effect transistor as well as certain disadvantage also. But now let us see the comparison between field effect transistor and bipolar junction transistor. Field effect transistor, as we discussed, it is a unipolar device, while bipolar junction transistor is a bipolar semiconductor device. In case of FET, the conduction of conventional current, that is because of only majority charge carriers. In N channel it is electrons, in P channel it is holes. While in bipolar junction transistor, the flow of conventional current, that is because of majority as well as minority charge carriers, and that is electrons and holes. FET is a voltage operated device, while BJT, that is a current operated device. We apply voltage across gate and source, and based on the level of voltage, the flow of conventional current is controlled. In case of BJT, because of a base current, the flow of current is controlled. Electronic noise is less generated in field effect transistor, while in BJT it is comparatively more noise is generated. In case of field effect transistor, the gain bandwidth product is less, and that is disadvantage, while in case of BJT, the gain bandwidth product is high. We have to take in case of field effect transistor that it should not be overload, while in case of BJT, no such care is required. In case of field effect transistor, there is no thermal runaway, and that is advantage, while in case of BJT we can observe thermal runaway. In field effect transistor, switching speed is very high, while in BJT compared to FET it is less. Input resistance in case of field effect transistor is very high, and that is why it does not load the source, while in case of BJT, input resistance is less. Field effect transistor is easy to fabricate. In case of bipolar junction transistor, it is difficult to fabricate, and it requires more space while integration. Now let us discuss certain advantage of field effect transistor. It has a very high input impedance, and that is why it does not load the source. And output impedance is very less, so maximum power can be transferred to the next stage. The noise generated is comparatively very less. Gain control is quite easy. Input capacitance is also very less. Frequency drift is also less, and the size is small. And application of field effect transistor. It can be used as a buffer amplifier, and that is a common drain configuration. It can be used in measuring equipment and the receiver. It can be used as a RF amplifier, and that is in common gate configuration. It is used as a RF amplifier in FM tuner and other communication equipment. It can used as a amplifier, and it is common source configuration. It can be used as a mixture in FM and TV receiver. It can be used as a AGC, that is automatic gain control amplifier in a receiver. It can be also used as a cascade amplifier, and as a cascade amplifier it can be used in test and measuring equipment. It can be used as a chopper in DC amplifier. It can be used as a voltage variable resistor in case of operational amplifier and AGC. It can be used as a voltage variable resistor. It can be also used as a low frequency amplifier. In case of a hearing aid and inductive transducer, it can be used as a low frequency amplifier. It can be used as an oscillator. In case of digital circuits, large scale integration and in computers, it can be used. It can be used as a constant current source in operational amplifier. So this is all about construction, working of field effect transistor. We have seen application as well as advantage of field effect transistor over bipolar junction transistor. So thank you very much for watching my video. Keep watching. Thank you very much.